Ladies and gentlemen, hello and welcome once again. Coming to you not quite live from One Take Studios, where my camera is fuzzing in and out. There we go. It has come to my attention that there's some kind of shadowy lines across my screen, and I also have noticed that I can't fix those. I think they're part of my camera, and I can't fix my camera right now. So instead, we're going to stick to the topic of solving linear inequalities. All right, solving linear inequalities, and really this comes in two forms. So I'm going to show you both side by side so that we have a delightful comparison between these two. All right, so we can solve linear equations with one variable or with two variables, and we're going to do both and see what the difference is. So if I have one variable, you notice that I have one number line. That kind of is on purpose because with two variables, I have two number lines. I've got my x and my y. I have a coordinate plane. Otherwise, the problems look the same. This says x is greater than 3. This also says that x is greater than 3. But with one variable, on my one axis, I find 3. Oh, look, there it is. Notice this says greater than but not equal to. That means that I don't actually want to put a dot at 3. I'm going to put an open circle at 3, saying I don't want to include 3, only the numbers that are bigger than 3. But I do want this to be my boundary, so that everything bigger than 3, everything to the right, is part of my answer. There we go. And that's going to go on for all of eternity. That means that 3.1 is part of my answer, and 4.726 is part of my answer. And I have unlimited answers, and they are all this direction. All right, so what does that change for two variables? Well, okay, I still want to say x is bigger than 3, so greater than 3, here's x-axis, 1, 2, 3, here we are. It still says greater than, but I don't want to actually do an open circle because I want to take into account the fact that I have a y-axis as well. So here's what we're going to do. At x equals 3, we are going to put in a dotted line. All right, this dotted line also goes forever and ever. But keep in mind that if I were graphing x equals 3, that would be a vertical line, and that's just what I put into place as a vertical line. The dots here, the dotted line, is kind of like having an open circle, saying that this is my boundary, but I don't necessarily want to include the points on this line as part of my answer. Now, when I go for everything that is bigger than 3, it's going to be everything on the x-axis bigger than 3, but it's also going to be everything on this side of the line, two-dimensional, x and y-axis. So every single last one of these points on this side of the line for all of eternity, these are all going to be solutions to this equation, because I can pick any ordered pair, again, x and y, any ordered pair. So say this guy right here is the point 5, 1. Well, 5, 1 has an x that is bigger than 3. That counts as my answer. Here, I would just say 5. 5 is bigger than 3. One variable. Two variables, ordered pairs. So all the points, every single point that's out here is part of my solution for solving this particular linear inequality. These are what is known as half planes. A plane in geometry is a flat surface, so think about the paper as being a plane, a flat surface. So a half plane means I'm going to cut my flat surface in half and choose half of it. So this is essentially me cutting it in half. I've got the left half and the right half for this, and I'm choosing half of it. So everything over here has an x bigger than 3. All right, so that being said, the rest of what we are focusing on today is going to be everything in two variables, ladies and gentlemen, because this is where I would like to be. So I need to think about graphing lines, so hopefully your line graphing skills are in a good place, and we will go from there. So here's our next example right here. I've got y is less than 3x minus 2. All right, let's see, that is in slope-intercept form. And what do I remember about graphing slope-intercept form? I'm going to start with, oh yeah, the -2. So -1, -2, that's my y-intercept. So -2 is my y-intercept. And then 3 is my slope. That's 3 over 1 if I want to write it as a fraction. So from -2, I'm going to rise 3, 1, 2, 3, and run 1. Rise over run, there we go. Okay, so now, notice this had greater than but not equal to. This one says less than but not equal to. So what I'm going to do is I'm going to very carefully graph a line to go with this, but I'm going to keep in mind that I want this line to be a boundary. I don't want this line to actually be part of my answer, so I am putting in a dotted line here. And this is one of the things that people just usually lose track of because they're like, oh, I'm going to make a line, and they forget to make it dotted. So less than, not equal to, dotted. I'll show you a counterexample here in a moment. Now, this is kind of weird, because now this is not like, this is just x. This is a left and a right thing because my x-axis runs left and right. This says that y is less than 3x minus 2. Well, ladies and gentlemen, A lot of textbooks at this point in time would have you say, pick a point, plug it in, see if it works. So for the fun of it, let's say that I pick, I'm going to go with this point right here. Boom, this point. That's 1, 2, 3, 0. 3, 0. Plug in a 3. 3 times 3 is 9, minus 2 is 7. Is 0 less than 7? Yes, that means I'm going to shade this direction. And you know what? That works. It does. I'm just really not fond of it because this means something to me. Y is less than the rest of the line. Here's my y-axis up and down. Here's my line. Where is y going to be less? Is y going to be less up here? I think not. Is y going to be less down here? Absolutely. So this says I want to go everything where y is smaller. Here's my boundary. Here's everything where y is smaller. I'm looking for everything on the underside of this line right here. All of these points, that's my really weird shading job. There we go. All of these points, for all of eternity, every point over here, if I plug any of these ordered pairs into that equality, it gives me a true statement. So this is my half plane. Everything below the line where y is less. That's how I like to process it. Okay, so one more example, different format, and there's two reasons for this one. One would be that I'm looking at something that's in a different form. So this was slope-intercept, which is a really nice graphing form. This is standard form, you guessed it, very nice. And with this, there's another way that I can graph this one pretty nicely if I remember something about, say, the cover-up method, if I use intercepts. So if I'm looking at this one, if I cover up x, if x is 0, that means that 2 times y equals 6. What does that mean? That means 2 times 3 equals 6, so y equals 3. 1, 2, 3, there's my dot. Well, what if I cover up the y's this time? Okay, what if y equals 0? I'm left with x equals 6. So 1, 2, 3, 4, 5, 6, x equals 6. There's my line. So different form, got to be on your toes, know which form you're looking at and how to graph. This I can use cover-up method nicely, so I did. Notice I was just pretending it was equal to. This one actually says x is greater than or equal to. So please be observant. Greater than, not equal to. Less than, not equal to. Greater than or equal to. All of a sudden with the or equal to, that little line right there, I don't want to use a dotted line anymore. I don't want to have a dotted boundary. I want to have a solid boundary. So I'm going to, there we go, so adjust slightly there. I'm going to put a solid line right here, okay? What that means is I don't only want to include the half of the plane that's being shaded, I also want to include every single point on this line, because if I pick a point on this line and I plug it in, it works. Let's say I pick this one. This is going to be 0, 3. 0, 3. 0 plus 6 is greater than or equal to 6. Well, yeah, since 6 equals 6, that works. So these ones, if I plug in a point on the line, it doesn't work because it's just less than, not equal to. Greater than or equal to, make a solid line. Did you make a note about that? I hope you did. All right, so now, well, again, I could pick a point and figure out if it works or not and decide my shading. And maybe I want to do that. I could do that. What if I showed you something, again, a little bit different? What if I were to get this y by itself? I could take my equation, which is x plus 2y greater than or equal to 6, and some of you might actually prefer this anyways, minus x. All right, so that is dropping 2y greater than or equal to 6 minus x, dividing by 2. Why is she doing all this stuff? I'll show you. I now have y is greater than or equal to 6 divided by 2 is 3, and that's 1x, so minus 1/2 x. Check this out. Y-intercept is 3. Great. Slope is negative 1/2. Down 1 over 2. Oh, look, that pattern still holds. Why do I like this form? It tells me exactly where to graph. Again, because it looks like this one, I have the y by itself. Y is greater than the line. I want the y's that are bigger. Here's my line. It's right here. Where are the y's going to be bigger? Above the line or below the line? Here's my y-axis. The bigger y's will be here up top. So I'm talking all these guys right here. Squeeze all these guys right here. Every single point on this half of the line is going to be a solution. Again, if you don't like that, that's okay. That's okay. Let's say I pick the origin right here. And I want to say, hey, maybe I should shade down here instead. So again, what that would look like is if I pick the point 0, 0, say, should this work for shading? Well, that means that if I plug into this, 0 for x plus 2 times 0 would have to be greater than or equal to 6. Well, that's 0 plus 0, which is 0. 0 is greater than or equal to 6. Last I checked, 0 was not greater than or equal to 6. Okay, so that's not a thing. And because that's not a thing, I don't want to shade over here. So if I plug in a point and it works, yay. If it makes a statement true, I shade. If I plug in a point and it doesn't work, then I don't want to shade over there, then I want to go for the other side. Quite frankly, to me, it doesn't really matter. If you want to plug in points, great. Otherwise, if you've got the y by itself, greater than, less than, above the line, below the line. All right, so your graphing skills have got to be good, and you got to pay attention to all of the details, lots of details here, but put some practice into play and you've got it, okay? Thank you.